Hello students, let's look at an example which combines subroutines, condition controlled loops and conditions and constants, where we can create some programs that will calculate area of square and circle. Okay, so the way I would start with this is if we wanted to create a program that could return the area of a square or return the area of a circle, we really want to sort of think to ourselves, what are the constants, what are the variables, and what are the subroutines that we need, and start abstracting them away from our main code. I would be inclined to import the math module so that we have access to an accurate version of pi. So I'm going to put that up first. And then I'm going to put a comment in here, constants. Now Python doesn't really have a true way of adding a constant variable like JavaScript does, but we'll put pi in capital letters just to show that it is a different naming convention than a normal variable that we're initializing. And we're going to access the math module and use the pi method, which is inside that. Now that gives us access to a nice, very accurate version of pi that we could only do so if we were using the math module. And that is a global variable, so the whole program has access to that constant. We don't expect pi to change anytime soon, you see. And then I will create another area called subroutines, sometimes known as subprograms. And these are going to be the two area calculating one. So let's just put area of square as our name. Just keep it really nice and verbose. We only need one parameter, and that is to know the side length. We're going to pass through a parameter here. And if we know the side, then the area, which is a local variable here, equals side times side. And then we can return area. Really nice and simple, okay? And the good thing is we don't ever have to write that again. Once we've got a function, a subroutine, we know this is a function because it returns a value, it's not a procedure. We can reuse this anytime we need to know the area of a square. And then I'm going to define another one saying area of circle, and then brackets, colon. Similar thing, I only need one parameter, which is the radius. And then I've got another local variable, so it doesn't really matter that it's named the same as the variable that was in area of square, because it's a local variable that's confined to that. So I've already got a constant called pi, which I'm going to draw from the global variable, and then times that by the radius to the power of 2, using two asterisks together. That's a mouthful. And then simply return them, or return the area. Really nice and straightforward, okay? So I've got two subprograms that do what I need to do, and then I can deal with the main program. And let's say I want to ask the user, well, let's first describe to the user what this is and what it's meant to do. I can say this program calculates the area of either a square or circle. And I'll put a new line in there as well. Why not? Just to make it more readable. And let's have a variable called myShape equals input. and that will be a string input. Enter a shape, S for square, C for circle. So we're asking the user, what do you want to find the area of? And then let's use the string method it would just initialize another variable called shape, and then we're going to say whatever my shape was, whatever they typed in, let's make sure it's uppercase, because even though we've asked for uppercase S and C, they might have had caps lock on the keyboard, so or they might have put an extra space in which case we can use things like strip. So we can sort of control what they put in really and force it to be uppercase. So this will make whatever they put in uppercase. So there's a string method being used there. We know it's a method because it's got this dot. All right. And then what we'll do is we'll have this while loop, a condition controlled loop, that while whatever they typed in is not S nor C, so we can write that by using does not equals C. So the exclamation mark equals is the equivalent in English of does not equal. So we're checking if it does not equal S and does not nor C, then we want to just keep asking them and bug them for an input. And then we can be a little bit more direct this time. Please enter S or C. And that sort of catches, if they type the wrong letter in by mistake or something like that. And we can do the same thing. We can make it uppercase. So it's just a little extra part to our program to show you how condition controlled loop can be used to force the user input to be either one thing or the other. And then we can have another part of our program using conditions. So if our variable shape does equal, so I've got two equal signs, big S, it's always going to be big S because we converted it with upper. Then let's say we use camel case here, side length equals a floating decimal point input, and then we can ask them enter a side or enter a length, a side length, that would do. Interesting. And then what we'll do, we can say area again, because even though we've used area here, it's a local variable. Equals area of square. So this is we're going to call the function here. We're going to call the function, and we're going to pass through side length, which is our variable that we've got from the user, which is an argument being passed through the parameter of side. So it doesn't matter that side length is named differently to side. It will be passed through as an argument into side, and it will be side times side, and that will give you the area. So underneath here, else, well, the only other option we have is circle. Well, let's make a variable, circle radius equals float input. The input subroutine always gives Python a string, so we have to explicitly change it into either an integer or a float. Input enter radius colon equals, and then it's fine, and we just put area equals, and then we're going to call the other function we made, area of circle, and pass through circle radius as our argument into the parameter radius. So we're done with our conditional statements, calling the different functions that we need. And then it's simply, we just need to print it out. So I'm going to use F formatter here. I'm going to say area equals curly braces, and this is where I put my variable in. So I'm going to say area. And if I want the area to 2 decimal places, I'm going to use a colon dot to F. And this special format here allows me to use string formatting to restrict the decimal points. So I just missed a little bit here. And shape. Get rid of that. We'll stop. Okay, so enter a shape. So I'm going to say C for circle, enter a radius. Let's use a float. Okay, name area is not defined. Okay, let's look. Let's have a look at the issue. Line 34. Line 34. Oh, well, I've got a dash instead of equals. That's the problem there. Let's try again. Enter radius. 4.7. Okay, there we go. And you see that area is to 2 decimal places because I use that formatter. And of course, because the F format is quite nice, because you could have, you know, meter squared or something like that if you were asked for units in meters or something. You know, so let's do square. So you can have a sentence in English, and within the curly braces, you can have your variables. So this is a nice little program that just combines some features that you might see in the Edexcel exam, where you've got your subroutines abstracted away from the main code. It's also decomposition. It's breaking the problem down into smaller parts that you can tackle individually. We've got constants here. We're using some space, white space. We're also commenting a little bit as we go, and also making sure that the names of both variables and functions give a good indication of what we're asking for. So this covers quite a lot of different criteria, a lot of different bases. So let's call this one. We'll do another video with some more examples.